Welcome to the Science 1 class. In this video, we are going to learn about Newton's law of motion. Newton's first law of motion. Newton's first law of motion is completely related to inertia. In the previous video, we have learnt about inertia and its type. Newton's first law states that every body continues to be in its state of rest or state of uniform motion along a straight line unless it is acted upon by some external force. That is, unless any external force acts on a body, the object will continue to be in its state of rest or state of motion. So, force can change the state of the object. Now, let's learn about the effects of force. That is, what all force can do. Force can either bring the moving object to rest or make the object at rest to move, or force can change the direction of an object. Now, let's learn about Newton's second law. Let me read the law first, then we'll explain it. Newton's second law states that the force acting on a body is directly proportional to the rate of change of linear momentum of the body, and the change in momentum takes place in the direction of the force. To understand Newton's second law, we should be familiar of three important terms. That is velocity, acceleration, and linear momentum. First term, velocity. In a particular time, the distance covered by an object is called its velocity. So, velocity v is equal to d by t, distance by time. For example, if you are walking, how much distance you are covering in 1 hour is its velocity. So, the distance covered by an object in a given time is said to be the velocity. And this can be called as rate of change of distance. Remember that whatever the term divided by time is said to be its rate of change of. So, velocity is distance by time taken. Next term, acceleration. When an object is in motion, its velocity will not be constant throughout. So, velocity will change from time to time. Change of velocity with respect to time is acceleration. So, rate of change of velocity is called as acceleration. That is, change in velocity divided by time taken. Next term, momentum. All objects will have mass. When you multiply mass with velocity, that is said to be momentum. When the motion is in straight line, it is called as linear momentum. Linear momentum is represented by the letter P, and P is equal to mv. That is, linear momentum P is equal to mass m into velocity v. Now, let's move back to the Newton's second law. It is stated that force is directly proportional to rate of change of linear momentum. Let's understand this concept with the well-known story, The Hare and the Tortoise. A rabbit is an animal which possesses higher velocity, and tortoise is an animal which possesses very low velocity. You all know that what happened in the race which was held between the hare and the tortoise. Finally, tortoise won the race. The hare might have won the race by following Newton's second law of motion. Let's see how. The mass of the rabbit can be taken as m. While starting the race, the rabbit's velocity can be taken as u, and its initial momentum pi can be taken as mu, that is, mass into initial velocity. After some time, that is time t, when the rabbit woke up, it might have seen the tortoise moving ahead. So what rabbit should have done? It should have increased its velocity, that is speed, by applying more force. Now, there will be a change in its velocity and it is taken as v. Mass m will be the same. So the final momentum Pf is equal to mv, that is mass into final velocity. So in the law, it is given that force is directly proportional to the rate of change of linear momentum. So change of linear momentum is final momentum minus initial momentum. That is mv minus mu. As it is stated as rate of change of, it means it should be divided by t. That is mv minus mu divided by t. And in this term, that is mv minus mu divided by t is directly proportional to force F. When you take out m, which is common in mv minus mu, we will be getting v minus u by t. Already we have learned what is acceleration. Acceleration is change in velocity divided by time. Here, v minus u divided by t can be replaced by acceleration A. Hence, force is directly proportional to mass into acceleration. If the rabbit have increased its force, its acceleration might have increased. So, it could have won the race. We have learned that force F is directly proportional to mass m into acceleration A, or force is directly proportional to rate of change of linear momentum, and this is called as the Newton's second law of motion. It is also said that change in linear momentum takes place in the direction of force. That is, direction of change in momentum depends on the direction of force. Direction of force will be always towards the end point. So the change in momentum also will be in the direction of force. And this is stated in the Newton's second law of motion. Hence, force F is directly proportional to ma, mass into acceleration. Meaning of directly proportional is, if force is higher than ma, mass and acceleration also will be higher. To equate this, we are introducing a constant k, which is proportionality constant. The value of k in all SI units is 1. So, when we apply the value of k as 1, we will be getting F is equal to m into A. That is, force is equal to mass into acceleration. And this is the equation of Newton's second law of motion. Next, we shall learn about Newton's third law of motion. This is a familiar law. Newton's third law states that for every action, there is an equal and opposite reaction. Let's see an example for this. Imagine that two persons, A and B, are standing opposite to each other and fighting. Suppose person A is applying force and pushing the other one, that is person B. And the person B can withstand only if he applies the equal force towards person A in the opposite direction. So, A should exert equal force on B and B also should exert equal force on A, or else they may fall. So force will be equal in magnitude and opposite in direction. And this is Newton's third law. Let's see a few more examples for Newton's third law of motion. An example with bird. We all know how a bird will fly. Birds will move its feather while flying. When the bird flies in the air will possess lifting force on bird's body. To balance this lifting force, bird will move its feathers down and produce a dragging force. So, only when the lifting force and the dragging force are equal, bird can fly with stability in the air. Because of this reason, birds will move its wings while flying. So here, air is exerting action on bird and bird is exerting reaction on air. Next example. When a swimmer swims, he will be pushing the water backward. Only when he pushes the water backward, water will push him forward. So swimmer will exert action on water and water will exert reaction on swimmer. When both, that is action and reaction, are equal and opposite in direction, The swimmer can swim. Okay students, that's all for today's class. In this video, we have learnt about Newton's first law of motion, Newton's second law of motion, and Newton's third law of motion. Thank you students. Have a good day.